In the electric circuit, we have UPN equal 12 volt, UL2 equal 4 volt, UL3 equal 5 volt. Give with justification the value of the voltage across the switch K. Here, the voltage across switch K, since it closed, the voltage is 0. So the voltage across the closed switch K is 0 since it acts as a connecting wire. Determine the voltage across M. Okay. Here we have the voltage of L2 is equal 4 volt. And since M and L2 connecting in parallel, then the voltage of M is equal to the voltage of L2. So UL2 equal UM equal 4 volt. They are connecting in parallel. Calculate the voltage U1 across L1. Here we have the voltage of L2, L3 and Pn. So apply law addition of voltage. Since L1, L2, L3 are series, UPN equal UL1 plus UL2 plus UL3 equal, then UL1 equal 12 minus 4 minus 5 equal 3 volt. The current carried by the lamp L1 is I1 equal 6 ampere, and the current carried by the motor M is Im equal 2 ampere. Determine the current I. Here we want to know the value of total current. We have the current flow from L1 is 6 ampere, and the total current approach and reach the L1, then the current across L1 is equal to the I total current. So law uniqueness of current, I equal I1 equal 6 ampere. Calculate I2 across L2. Here we have the Im equal to, and we know the current across L2. Since they are parallel, so Im plus I2 equal I. Since they are parallel, so I2 equals 6 minus 2 equal 4 ampere. An oscilloscope is connected between B and C, between these 2 points. The luminous line is displaced vertically upward by 2 divisions. Calculate the vertical sensitivity. Okay. To find the vertical sensitivity, we know that U between B and C is equal SV times Y. We have UBC and Y, then we find SV equal UBC over Y, 4 over 2 equal 2 volt per division. If we reverse the connection of the oscilloscope, how does the luminous line displaced? Here, if we reverse the connection between B and C, so we get a negative value, and the horizontal line is displaced downward by 2 divisions. Consider 2 resistors, R1 equal 100 ohm, R2 equal 300 ohm. 1. Calculate the resistance are equivalent of R1, R2 in the following cases. R1 and R2 are connected in series. Since they are series, so we will add R1 and R2 to get R equivalent. which is equal to 400. R1 and R2 connected in parallel, so we will apply the formula of parallel connection of resistor. R equivalent equal R1 times R2 over R1 plus R2 equal, we will replace their values to get 75 ohm. We connect in series the resistor R1 and lamp L of voltage UL 3 volt, lamp L, to the terminals of the dry cell of voltage UPN 12 volt, and the current I is 90 milliampere as shown in the figure. Determine the intensity I1 across R. Here we will find the current across R. If we notice that the current flow from the generator or the battery, it will reach to the point A and enter the resistor R is same of I1. So the current across R is equal to the current, the total current. So I equal I1 equal 90 milliampere. Deduce the value of voltage UAB across R and the voltage UBC across L. To find the value of UAB between A and B, we have the current and the resistor, so apply Ohm's law. UAB equal R1 times I, we will get 9 volt. Here we will convert the value of current from milliampere to ampere. We will divide 90 over 1000. Now to find the value of UBC, we have the voltage UPN and voltage AB. Since R and L series, we will apply law addition of voltage. To find UBC, we will get 3 volt. The lamp L functions normally. Explain. The lamp L functions normally since the voltage of UBC is 3 and the voltage of L is also 3. We replace R1 by a connecting wire. Determine the new value of voltage UBC across L. Since R is a connecting wire, so its voltage is 0. So the current through UPN is equal to the voltage of UPN is equal to the voltage of BC. So the voltage BC is equal to 12 volt. UPN equal UBC equal 12 volt. Show that the lamp may burn out. Here, since the value of UBC is 12 and the value, the voltage of lamp is 3, then the lamp L is burned out. A generator delivers a voltage visualized on the screen of an oscilloscope as shown in the figure. Here we have SV equal 5 volt per division and VB or SH, they are the same, equal 2 millisecond per division. Specify the nature of voltage of the figure. This form of voltage is alternating sinusoidal. Calculate the maximum voltage and effective voltage. To find the maximum voltage, we have SV, and from this figure we can find the amplitude Y, which on the vertical line, the maximum or minimum. So U maximum equal SV times Y equal 10 volt. To find the effective voltage, we will divide the maximum voltage over radical 2. So we will get 7.07 volt. Calculate the period and the frequency. To find the period, we will look on the horizontal line. Here we have VB, then we will find the X. To find X, we will find 2 points having the same direction. We will take this point and this point since they have the same direction. So T equal VB times X equal 12 millisecond. Then we will convert from millisecond to second. We will divide 12 over 1000 to get 0.012. To find the frequency, we will write the formula frequency equal 1 over 2 equal 1 over 0.012, which is equal to 83.33 Hz.